So next up, we have designing beautiful boards. Let's see here. I'll get the Kliment's introduction here. Oh, I had it up. There we go. So this is Kliment is a hardware person and does electronics for fun and profit. Is a member of the KiCad library team, teaches occasional workshops related to electronics, and is involved in the design and prototyping of various event badges. He has also been featured in multiple KiCons in the past and FOSDEM talks. He is a prolific artist of the PCB variety. Please give a warm welcome to Kliment.
Hello, everyone. Yeah, this was going to be making beautiful PCBs, but actually it turned out to be more of a working with artists talk. So yeah, I've had the pleasure to work on a number of really beautiful designs with some extremely qualified designers and artists, and I wanted to tell you a bit about that. This is what I want to talk about today. So why bother with this at all? How to do it? How do PCB people and art people work together? What kind of things are possible to make as PCB art? How to actually put it on a board? And I'll show you some examples of what it looks like when it's done. Yeah. So first question, why bother? Lots of people ask me, like, why are you putting all this stuff on your boards? Like, nobody will see it, and it's hidden in the device. And like, I don't care if nobody will see it. I'll see it. I know it's pretty. And more boards are actually designed to be on display, and are no longer hidden in cases, but are actually a feature. And yeah, actually working with artists is really, really fun. So like, I don't pretend to be an artist. I sometimes draw cat pictures, but yeah, like I'm nowhere near the level of what like professional designers and artists do. And being able to work with people who are really good at this and actually produce something pretty, like way prettier than I could ever do, is really fun. Yeah, functional things can be gratuitously pretty. As in, like, they don't need to be, but they are. So I like to go to, like, museums and look at old machinery. And often on old machinery, you'll have, like, lion feet instead of just, like, normal feet, or, like, handles with, like, pretty carvings on them. And that's just somebody whose job was to do that thing, just showing off. And, like, I'm really good at this, and I can make it pretty. And there's lots of examples of this in architecture. For example, in the center of Vienna, there is a waste incineration plant, and it's in the center of Vienna. Nobody wanted a big, ugly industrial building in the center of Vienna. So they have a big, beautiful industrial building in the center of Vienna. So this is a waste incineration plant and combined heat and power plant. And every surface that was blank was just filled with random beautiful stuff. And there's no reason we can't do that on PCBs as well. Like, there was a blank surface on this. This is one that C-Presser sitting in the back there made. And there was a blank spot on it, so why not put a shark on it? Yeah. And you can also make boards that are actually designed to be art. Yeah. Or they can be functional, but their function is to make you look pretty. Or, like, you have this is a sensor board, and there was space on the back. Nobody will ever see it, but, like, who cares? You can put a nice pattern on it just because it's there. It doesn't cost you anything more. So yeah, I mainly wanted to talk about how to actually work with art and design people as a PCB person. I'm more of a PCB person. If you are both a PCB person and an art person, that's awesome, and keep doing that. But if not, you're going to have to figure out how to communicate, and there's an impedance mismatch there. So you have a lot of internalized knowledge, and so does the other person, and you're going to make a lot of assumptions about things, and they're going to make a lot of assumptions about things, and you're going to need to find a common language. And one thing that has been a particular issue is understanding the impact of decisions. So something that seems to the other person like a small change can have enormous impact. Like, I'll go back to this point in a bit with some examples. But yeah, so what you want to do is you want to explain what's possible. And this works best by showing lots and lots of examples of things you can do. So just to make it clear to the other person, like this is what the medium can do. And then set constraints. Like, we can do this, but it will make the board not work. Or we can do this, but it's going to be a massive, massive pain to make it happen. And then get out of the way and let the other person do their thing. So I've sometimes gotten into the situation where, like, I'm working with a designer and the designer is really good, and I have a stupid idea and I try and bring it in, and then at some point I notice, what am I doing here? Like, this is why I'm working with a professional, right? So, like, get out of the way, let them do their thing. They'll probably do it better. Yeah. And you will often have to explain design rules in an unusual way. So to somebody who's never done PCBs, like, how do you explain space and trace? It's like, okay, let's start with brush sizes. Like, yeah, every feature needs to be painted with this kind of brush size, and then they do that, and then the gaps between them, because they painted them with a brush size, but like the gaps between the brush strokes are smaller than the brush size, it doesn't work. So, like, you need to communicate things like this, which is like, these are the technical constraints of this medium. Like, you can draw this, we can send it over, but they're not going to be able to manufacture it. So yeah, I spend a lot of time like looking at a really beautiful design and then measuring bits and saying, no, this needs to change, this needs to change, this needs to change. And communicating this up front is really helpful. And yeah, we want to actually, like, if we have a functional board, like a board that is not just for art, we want it to stay functional. This can be impacted by things like having a copper exclusion zone somewhere where it breaks up a ground plane. And I've had this situation as well where, like, we were working on a board that was like under the sea themed, and it also had a radio on it, and the artists proposed this wonderful like patchy pattern all over the surface that just broke up the ground plane, and the radio wouldn't work anymore. So then, like, changing that was really, really high impact. So I basically, at that point, we had to like reconsider how the art in that part of the board was going to work altogether, because the concept that they had was just not compatible with the technology. And communicating this is somewhat difficult. I've come up with some methods for this, and the people I've worked with have come up with some methods that work for them, and I'll come back to that. But having the other person have an understanding of how much impact their decisions are going to have in terms of implementation is very useful, because then they know like where their freedom of movement is. So in terms of workflows, you're going to want to agree early on the dimensions and or shape of the board so you can make a template. And at that point, you want to do a round trip. So like export a template, have the artist draw on it, anything, whatever, draw a cat picture, put it back in, make sure it actually imports correctly, everything's the right size, everything's on the right layer, and it looks like they expected it to look. And then you can like let them go away and do their thing, and you can go away and do your thing and then come back. So once you have a rough layout, you can annotate things, like literally draw on things and don't touch this area or do whatever you want in this area. And then you can go away and work in parallel. So like you work on the layout, the other person works on the art. And then every once in a while, check in with each other and see whether disasters are happening. Because with this kind of thing, you're never like communicating in the correct language until you've done a few projects together. So yeah, let's look at what we can do. Are my pictures? Yeah. Yeah, let's look at what we can do. So this is something that also to somebody who's never worked with PCBs before, you need to explain what is a PCB, what is it made of, what is the manufacturing process. So like, yeah, we have fiberglass core, we have a copper pattern that we control. We can control the solder mask openings, where the vias go, and we have this surface of the board. So that can be gold or silver, which gets plated on every exposed bit of copper. We have silk screen, which we can print on, and we can mill the board to a particular shape. And we need to translate this, right? So yeah, fiberglass is translucent. It's a kind of brown beige material that shows up. And the copper is opaque and blocks light from coming through. And the solder mask is paint. And that can be in a range of colors that depends on who's manufacturing it. And the same thing is true for the silk screen. And every mask opening has impact depending on what's under it. So it may expose the bare PCB material. It may expose copper. If it exposes copper, then that exposed copper is going to have surface treatment on it, whether we want it or not. So that's going to have a visual impact. And we can look at this on a PCB. So this is a PCB that uses every possible combination of layers. So we have the silk screen, this white stuff over here and over here. Then we have negative copper. So we've removed the copper underneath the mask. And this gives us this different shade of green underneath. In this case, the solder mask is green. But of course, depending on what solder mask color you pick, you're going to get a different pair of colors. So you always get two different colors with and without copper under the solder mask. And then if you open the mask and there's no copper underneath, you get this brown beige color, which we have over here. And if you have copper and no mask opening, you get this like shinier, in this case, lighter green color. And if you open both, then you get your surface treatment, which in this case is NA. And being able to show something like this, it really makes it clear what the possibilities are. And like we have a palette of 5 colors. It's not much, but they also have texture variants. And we can kind of control what these 5 colors are by changing the silk screen and solder mask color. So this really shows the person you're working with, like what the possibilities are, and then they can play around with this. On this particular board, this entire area in the middle has no traces. So everything here, it was reserved for art, and all the traces are around the outside, and they're kind of hidden under the silk screen and on the other side of the board. So there was a lot of area for the artist to play with. Yeah, this is a way to kind of get a color gradient. This is a board made by Tilde Industries from a very long time ago, and it uses a halftone technique. So it uses circles of varying size to create a kind of color gradient over here. And you can take this to a quite extreme level. And these are all individual dots of silk screen. And if you send the board like this to a manufacturer, they're going to complain at you massively. And sometimes their cam will crash because like there's thousands and thousands and thousands of dots of silkscreen here, and they can do it. Like this, this is a photo of a board. I have the board with me if you want to look at it later. So like it's proof that they can do it, but their software may not be able to do it. Right. Yeah. So about tooling, I really like working with open source tools. The person you're working with may have their own choice of tools. In this case, like the last few collaborations, it has worked out because we all love Krita. Krita is like the best painting tool ever made, and you should all use Krita. Yeah, I use Inkscape for some vector pattern stuff and for vectorization. A lot of people who are professionals in this field tend to use Affinity Designer or Adobe Illustrator, and that can also export vector graphics, and those work as well. But like if I'm doing something myself, I prefer Inkscape because, well, it's open source and it's great, it works. But yeah, I'm not an artist, so don't listen to me on this. Yeah, and finally, KiCad's graphics import from vector files works well. This was not the case for many years. And now it's at the point where I can just import graphics and I don't have to care whether they're closed or open shapes or whether they're filled or whether they have multiple lines. Everything will just kind of work out. And it's great. So finally, no need to round trip through bitmaps. It all just kind of works. So you can now do like professional grade PCB art with entirely open source tools and without any external stuff. So this is great. So I wanted to describe the workflow that we've settled on the last few projects. So first of all, agree on the rough structure and shape of the board. So changing the shape of the board is the most annoying thing to do because it impacts pretty much everything else. It impacts art, it impacts layout, it impacts panelization. There's a lot of things that you don't want to be changing at a late stage in the process. So yeah, agree on the shape of the board. You don't need to like completely settle this. You can go like, okay, this side of the board and this side of the board, they need to stay as they are. Everything else, do whatever you want. Yeah, and then do a rough layout so you know where your parts are going to go. And then you want to export images and vectors from KiCad and then draw on them. So yeah, I just use a graphics tablet and I draw on a separate layer like this area, don't touch anything there. This area, do whatever you want. This area, like no copper changes, but you can do whatever you want on silk screen. This area, don't touch the silk screen either. And like just doing this graphically really, really, really helps because then like your artist can import this in a reference layer and check whether like they're going to mess with your work. So then at that stage you can do design and layout in parallel, but every once in a while you want to import the design and see whether things make sense. And you want to do your first import before anybody puts a lot of work into anything to make sure the process works. So for the PCB export, you want to export the board shape. That's edge cuts as SVG. You can put annotation on user layers at this stage, so you don't need to paint on things. But yeah, you'll end up doing that anyway. So yeah, then export all the copper layers, silk layers, mask layers, all of that needs to be in the final design. Export those as SVG. And then export an image as orthographic view from the 3D viewer of both sides of the board. So then like the person doing the art can then import that, have that as a reference image and literally paint on top of it and see how things are going to work. And at that stage, you can also do that export with different color silkscreen, different color mask to help make decisions on what you're going to use. So on the art side, in Krita, we ended up having layers for copper and mask and for the silkscreen. And the copper and mask layers are negative. So they're where the mask openings are and where we're taking copper away. And the silkscreen is positive, so where we're adding silkscreen. And we had reference layers for everything, both in vector layers and as images. And there you need to be really careful that if you have a back layer, it's mirrored correctly, because what you're exporting is usually how it looks. So it's going to be mirrored when you put it back. And then settle on roles like no silkscreen on top of mask and minimum brush sizes. And one thing that's really useful to have is have an alignment feature. So like we had the line that was always in the same place on all the layers. So then when you import them, you can then align everything together. And we had a scale check feature, which is like a square of 1 centimeter. And then that imported as a different size when going from Illustrator. So that's always fun. So 1 centimeter in Illustrator is not 1 centimeter in KiCad. There's a scale factor. And we set up some rules like things that the art should not do. And then on the art export, ideally you want to be exporting everything as vectors, because vector import in KiCad is now so lovely. If that doesn't work, you can still vectorize it before the import, which I recommend you do. And this is something you give to your artists for when they're doing the export. On the import, vectorize things if they're raster, and then you do file import graphics and you get a group. This is awesome because you can move everything as one thing, but you can also enter the group and edit or delete individual things that get in the way. So this is great. If you're importing negative copper, you want to put that on a user layer. And then you want to convert it to a row area and then put a filled zone underneath with no islands removed. There's some tools for automating all this art to KiCad process. There's Gingerbread, which is really nice if you're using Affinity Designer or Illustrator, because the scaling is then not broken. And this is a highly automated process. You drop an SVG from the tool in, and it puts KiCad stuff into your clipboard, and you paste it into KiCad. However, it requires a fair bit of setup on the art side, so all the layers need to be named the right way. And with Inkscape, it sometimes doesn't recognize some shapes correctly, but it's highly automated. And there's also Gerbalize, which will eat literally any SVG, and that's a really powerful tool because it lets you take a ready exported Gerber and put art into it. So this way, the art is entirely independent of the PCB design and can be added afterwards. This has advantages and it also has disadvantages. So it's much harder to do co-design that way, like designing in parallel with PCB layout. But it's really nice for adding art onto an existing design. So let's look at how these things work. So this is a board which it's a single board pad detector made by a wonderful person in the UK. And this has in silkscreen a half-tone picture of a bat with incredible detail. So the individual dots on here are way below what the PCB manufacturer claims to be able to make. But it works out. This is the badge from the Easter Hack 24 event that happened last Easter. And this is a PCB with black solder mask and white silk screen. And they're also using all layers here. So they have their PCB, they have lots of exposed ending. This area here and a lot of other areas actually are exposed on both sides, and there's LEDs behind that can shine through the board. And there was a challenge that went with this. So if you solved some puzzles, then you could get some add-ons to this board, which turned the bunny into a cyber bunny. And this is basically the same process, but with purple silk screen. Purple solder mask, again, white silk screen, and then ink. And they're using this copper or no copper under mask a lot to get these shapes and textures here. This is from the Fright Camp badge, and this one has a pattern in the copper under the solder mask. So this is black silk screen and white solder mask, which gives a completely different effect than the other way around. So the textures are very different. And again, it's using ENIC for highlights. Yeah, on the other side of this board was actually something that's a common problem. And this is the art people and the PCB people working separately and not checking in with each other frequently enough. So this is a part that was meant to be soldered by people on site. And these areas around it are ground, and this thing here is VCC. And this is a 0.15 millimeter gap, which is fine for DRC. However, DRC complained quite a bit about mask openings bridging nets. This was made in Altium rather than in KiCad. And I asked the person who made this, like, why didn't Altium warn you about this? Like, yeah, Altium did warn us about this, but like, it warned everywhere, so it switched that off. So, yeah, when DRC says something is bad, trust your DRC. Run DRC. Okay. Yeah, this was done entirely as a vector design. I think this was actually in Inkscape. And you can see the interaction between the different layers here. So like we had to cut gaps in the silk screen so it doesn't cross the exposed copper. And we're doing a lot of funky stuff with copper exclusion zones. So this actually took a lot of collaboration to make sure that like all these copper exclusion zones will not actually interfere with the function of the board in any way. This was nice and easy because this was on 4 layers, and I just didn't put anything on this layer. So there's nothing on this layer that's actually connected except vias. So we just had to be careful that none of the vias actually intersected with the exposed copper. Yeah, but it's a really nice subtle texture with the vias and the missing copper in these hexagonal shapes. So it's not very visible until you look at it closely. Yeah, the other side you've already seen. This is a bit of a wider view, and you can see the kind of details you can get. Like these flowers over here, you have exposed ending. This is actually a critical ground path. So I was like, can you put a few more flowers there so that we close the ground path? So yeah, this flower wasn't originally there, but now it is. Yeah, in the middle of each flower is a area of missing copper. And inside the sunflower, we also have missing copper, which is used to make this pattern under the mask. This was not actually intended, but under the silk screen, you can actually see the pattern of the subtracted copper. So that turned out kind of fun. And for this here, to actually get these features in there, we actually have an extra bit of copper which we have to add in here. which was implemented by subtracting that shape from this exclusion shape here. Yeah, you can get incredible detail with mask. So you can see like the silk screen here is fairly large and blobby, but the mask details are really precise. So yeah, again, make sure to communicate this because like depending on which layer you put something on, it's going to have different constraints on how much precision you can get. Yeah, yeah, this is my cat, one of them. Yeah, I wanted to show here the translucency of the actual FR4 material of the board. So you can actually, like, if you shine light through it or if you backlight it, it's a really good diffuser of light. And it also has its own color, which is this, it looks brown if you look at it like here. But once you shine light through it, it's actually more of a greenish, yellowish. So you can use that to great effect if you have a backlit board or a board that's going to be a panel put in a window or something like this. Yeah, so that's what I wanted to tell you about. So go ahead and make beautiful things. I put this talk exactly as it is at this URL, but don't open it now because it's like 30 megabytes that is going to load, so it's going to overload our network connection here. But yeah, feel free to look at it later. We have a workshop tomorrow where we're going to actually do some of this. And I'll bring cat pictures, and you can bring other pictures. We can do some sketches, and we'll go into a lot more detail of the actual export and import process. But yeah, I wanted to give you a structure of what it's like. So, any questions?
So bring your cats and bring your KiCad.
Hi, I was wondering, especially with your CAD PCBs here over here, you have quite irregular outlines, and there were the remainder of the tabs probably from the production process. Is there any way to minimize this, or is it a fact you have to live with?
Okay, there's some manufacturers that are much better for artistic boards than others. This one was made by Oshpark, and their depanelization method is cut these tabs to a sharp point, which is a bit annoying with shaped boards like this. If you can find a manufacturer that does full routing and ideally then cleans off the depanelization marks as well, that's ideal for this kind of thing. If not, you may have to communicate with your PCB manufacturer about where to place these, like how to do the panelization and where these marks end up, so they can end up in a place where they're not so critical. So if you look at these boards, for example, we actually ended up having a fixture made for assembly, so that we could have them routed all the way around so that they would have no sharp edges anywhere.
Oh, thanks for the talk and thanks for all the pictures. It's really nice to look at all the PCBs. A few years ago, we tried to design a badge for an event, and we had some like copper areas that we wanted to mill through, and we gave that to JLC PCB, and so they just silently corrected that error that we're milling to that traces. They moved them to the side. It looked okay, so it was fine, but I can imagine when you give them designs like this, they try to correct stuff because, well, they do autocorrect and they do error identification and stuff. How do you work around that?
Okay, so the same way you talk to your artist, you need to talk to your PCB manufacturer. You're doing weird shit. They're not used to this, okay? You're breaking their process, you're crashing their servers, it happens. Yeah, talk to them. Say, we're doing a weird thing, what's the best way to do it? And if you have a PCB manufacturer who is willing to talk to you about this stuff, like I will sometimes sit down for 2 hours with a PCB manufacturer and go like, how do we panelize this thing? And we're going to go through a bunch of things and we're going to come up with some crazy shit that I never even thought of ever. And yeah, so if you're doing weird things, you need to communicate a lot more than if you're doing just standard stuff.
Maybe I missed that, but if you have a fancy outline that is defined by the artist, you didn't mention that in the workflow. So how does the artist define the outline?
Okay, so ideally you want the outline exported as a single vector polygon. So I had a slide, I think, on export somewhere. So if you're exporting art, yeah, so one SVG for board shape. So you want that as a separate file, and you want it to have a single outline, and then you can import it directly onto edge cuts. And if your scaling factor is correct, or you're not using Adobe Illustrator and everything is correct to start with, then things will just work. So you get a shape. Now that shape may not be manufacturable. So you need to again communicate with your PCB manufacturer, communicate with your artists, find a common ground, because like you cannot mill sharp inside corners, and things like this are something you need to communicate.
I have actually an annotation to the tool Gabolize or Gabonara. They come together. So you can directly work on the Gerber files, but it also has a really nice feature that you can make your SVG file into a footprint. And that footprint will also have all the technical layers you want. So it will have copper, it will have mask, it will have silk screen. So if you don't do full board art, that's quite a nice way to go about it.
What's your experience with using the FR4 base material? Does it? I think it sometimes can have marks from the manufacturer that might become visible when exposing it. Is this a common issue, or what's your experience?
Okay, so the FR4 material gets marked internally. So inside between the layers of fiberglass, there will sometimes be like a label from the manufacturer saying like, this is this product. And I have seen these, but they're so rare that I wouldn't worry about it. So you get like 1 or 2 of these on a giant sheet of FR4. And yeah, if it happens to hit the spot where your art is, then it's a limited edition board. And
in a functional board, you may need to put devices on later by soldering or whatever. Can this be part of the art?
yes. Okay, so the parts that are on the board can definitely be part of the art. And again, this is something where communication really helps. So like you can have your designer put in guidelines for where like your part should be aligned for symmetry or to fit into a pattern. You can, yeah, let me see if I have a good example. I do not. Yeah, so like here we place this gear on a via. So the same way you can place shapes around parts, or you can have things in the art that leave space for parts. Like yeah, I know I don't have a good example at the moment, but yeah, you can definitely incorporate the parts into the art.
Okay, thank you, Kliment.